Hi students, now we are going to derive an expression for the average kinetic energy per unit volume, which is also defined as energy density. So energy density means what? It is the energy per unit volume of the gas. Now let us consider an ideal gas. The total energy of the system is given by epsilon or capital U is equal to total number of molecules into kinetic energy per molecule. Now we have studied that the total internal energy of a system is equal to the sum of the kinetic energy plus potential energy. But for an ideal gas, the potential energy is equal to 0 because we have assumed in the kinetic theory that there is no intermolecular force of attraction. Therefore, the total energy will be kinetic in nature. So, if you add the kinetic energy or the average kinetic energy of all the molecules, if you add, the total energy will be equal to the internal energy of the system. So, U is now equal to the total number of molecules. So, U is now equal to capital N into the average kinetic energy per molecule. So, this is equal to capital N into 3 by 2 kT into 3 by 2 kT. So, U is now equal to 3 by 2 N into Boltzmann constant K into T. So, this is equation 1. But for ideal gas, this NKT is also equal to PV. Is it not? The ideal gas equation in terms of number of molecules is what? PV is equal to NKT. So instead of NKT, what shall we substitute is PV. Is it not? Therefore, now U is equal to 3 by 2 PV. 3 by 2 PV. Okay. So this energy per unit volume we require. Is it not? So I will write here the energy per unit volume. So V is brought to the left hand side. So what will be the remaining term? This only is equal to what? That is 3 by 2 P. So this is 3 by 2 times P. Therefore, small u, this is energy density which is defined as energy per unit volume. So instead of U by capital V, I can substitute what is small u. This is the energy density which is also the average kinetic energy per unit volume. So this is now equal to 3 by 2 into P. So this is one of the expressions. So let us call this is equation 2. Okay. Now we have already studied that the pressure of the gas is equal to what? P is equal to 1 by 3 into N into M into V square average. Isn't that? So that also can be substituted here. Therefore, U, small u is now equal to this 3 by 2 multiplied by P. Instead of P, what we are substituting is 1 by 3 N M V square. Okay. So this 3 is cancelled. So now U becomes equal to half into N into M into V square average. But small n is a number density. So this is also equal to total number of molecules per unit volume. So this is a number density. And therefore now small u is equal to 1 by 2. In place of small n, I am going to substitute capital N by V. So this is N by V into mv square. This is average. So this is now equal to 1 by 2 into capital N into small n divided by V into V square average. But N into small m, the total number of molecules multiplied by mass of one molecule is giving that molar mass capital M, because we have taken 1 mole of a gas. Is it not? So this is a total number of molecules into mass of one molecule will give the total mass of the entire system. So I am going to substitute here. Therefore, now U is also equal to 1 by 2 into capital M divided by V into V square average. So the total mass of the gas divided by the total volume is called as what? Mass density, or simply density rho. So this m by v is also equal to rho. This is equal to the density of the gas. Therefore, we get another expression for the energy density. So, U is now equal to half into rho into V square average. So, this is another expression for the energy density. Now, equation 2 is energy density U is equal to 3 by 2 times P, and it is also equal to 1 by 2 times rho into V square average. Okay, I hope you must have understood well. Fine.